Hello, good day, folks. Today we're going to talk about how to add vectors algebraically. Now, this is going to be very important because this is a lot of what we're going to be doing this year and this semester. So here's the question. Now, on this, I'm going to say, remember, vectors are basically a magnitude or direct with a direction. So here's a direction. And this could be velocity, it could be force, or it could be a distance traveled. So let's go 10 meters per second, and he's going east. So to refresh our memory, if we got the compass point, what we call compass rose, this is north, south, east, and west. North and east are positive, south and west are negative, and we're going to, for the most part, this is going to be true. Honestly, if you got something going south and west all the time, we can use positive values because we know we're going west and we're going south. Just be careful. Make sure you understand what's going on when you're dealing with this. But what happens if we're going at an angle? See, and this is where we have to use the components of the vector, which are these two, the x and y components of the vector, which are actually two other vectors, to add to this. So we're going to add vectors head to tail, and we're going to end up with a different vector, what we call the resultant. And that's what we're looking for with all of these. Now, the directions are going to be interesting. So if we look at this problem, this example, and the first sentence is background. What's happening? Why are we doing this? It has nothing to do with solving the problem, but gives you an idea in the back of your head. Say, okay, we're traveling somewhere. Okay, we got a seaplane. You didn't say seaplane, but that's what a plane that takes off and lands in the water is called a seaplane. And it flies from South Point to Honolulu. And it does it in 3 stages. All right, so we got 3 vectors. So the first vector is this guy, 83 kilometers at 22 degrees west of north. This is going to be important. So let's go back to here. And let's look at the compass point. Compass rose again. This is north, and we usually assume this is 0. We're assigned 0 degrees. 90 is east, 180 is south, and 270 is west. Now this is, again, I'm just reviewing all this. Now what would mean is that a lot of times, well, when you're in an airplane, they're going, say, 45, let's say 45 degrees. So they're traveling at a bearing of 45 degrees, which is this. This is basically 45. And this is going to be 135 if we go directly to the southeast. This is northeast. So with this, we're giving you the direction bearing. But a lot of these problems you're going to see in the assignment go 45 degrees west of north. So it's the west of north. To interpret this, north is the primary axis, and we're going 45 degrees west of north. So you go from north and you go west 45 degrees. So this angle is 45 degrees. What is, you should realize that this is going to be, let's see, 315 degrees, the direction it travels. But a lot of times we're just going to say 45 degrees west or north, or 20 degrees west or north, or 40 degrees south or west, or west or south. So if we go 20 degrees south or west, here's my 20 degrees. If it's west or south, it's going this way. So you have to look at how this is written. This should tell you, help you with the angles that we're going to look for. So here's our first slide. Here's our first angle. So I'm going to go here. I'm going to go 83 kilometers at, I believe it's 22 degrees west of north. I'm just going to abbreviate west or north, and that should be 83. Yep, 22. All right, then the plane flies. Here's the second vector. 146 kilometers, the distance and the direction, 21 degrees west or north. So it's not going to be 21 degrees west or north. So it's not a big change in directions, but significant. And it's 146. So I'm going to put 146 down. Now the last vector, remember we're in 3 stages, is this one down here. Finally, the plane flies 152 kilometers at 17.5 north of west. So it's going more west than north. And we want to know the resultant, the final displacement. So 152, 17.5. Okay, no converting of units. We're going to keep everything kilometers. And this is the one thing about adding vectors. If everything's the same unit, you don't need to change everything. The only time you need to convert units if one or more measurements magnitudes are different units. So we're all going to keep this in kilometers. Now, we either go north or west. So we're going to start my compass rose here. We're going to start our initial compass rose, and I'm going to keep with blue. And we're going to go 22 degrees west or north. So if this is my north, this is 22 degrees. So we're taking this way. At the end of this vector, so the magnitude here is 83. So I'm going to put 83. I'm going to draw another compass rose. Remember, when we add vectors, it's head to tail. So I'm going to put the tail of my second vector here. I'm going to go 146, a little bit longer vector, and this is actually going to be 21 degrees from west or north. So we'll get north, and we're going 21 degrees to the left or towards the west. Stop, put another compass rose, another cross. Remember, these compass roses, I call them compass roses because that's the actual name. It's actually a small little cross where we put our directions down. Now, we're going more westerly now. It is west is our main axis, and we're 17.5 north of it. So we're going this way, and here's my angle of 17.5. You don't have to be accurate with this, just somewhat close. Because you notice I haven't measured any of these angles. I'm just saying this is what it looks like. Now I'm going to change my pen color. Okay, let's go with a magenta for this vector. So what I'm going to do is draw this, and this is my resultant. This is my answer. So the answer is going to be in 2 parts: a magnitude. I want to know the distance, the displacement. So I need the magnitude and direction. And we're looking for this angle or this. It depends on how we want to look at this. Now, what we're going to do is we're going to take each of these vectors, the blue vectors, and find the components. So vectors 1, 2, and 3, x and y components of each of those vectors. And so I'm going to draw this. Here's my x and y. X and y, x and y. So I'm going to take these blue vectors apart and have the components, the x and y components. I'm going to add all the x's together, all the y's, and what we're going to end up with, I'm going to change my pen color because hopefully this will be easy to see. So what I want to do is have the components, I'm going to do these in red, have all the x's in one, this is sum of all the x's in one area, sum of all the y's in the other. So add up all the x's, add up all the y's, I'm going to end up with my resultant. And here are the components of my resultants, my x and y component. Now, let's do this stepwise. Let's find this x and y, this x and y, this x and y. So I'm going to go to my next slide. You guys could do this. It's going to take a little bit long. This is why the test lasts an hour and a half. So first one is going to be 83 kilometers at 22 degrees north. So here are my x and y. Here's my 22 degrees. This is 83. This is my adjacent. This is opposite. Now we're going to do trigonometry. So sine of 22 degrees is equal to, let me think, it is going to be opposite over hypotenuse, where my opposite is going to be the x direction. I want to make sure that's correct, because even I get this thing mixed up. So let me do a... Yeah, it is the opposite. Oh, thank God. I remember something. So hypotenuse times sine of 22 degrees is going to give me my opposite, or my, actually, excuse me, this is my y value. Make sure I get that right. It is the opposite, but it's actually the y value, not the x. So get your calculator out. So 83 times the sine of 22. That's going to give my y direction. Excuse me, that is x, y is up. X, I had that right the first time, it's going to be 31.1. 31.09 rounded to 31.1. And therefore my y is going to be 83 cosine of 22. And that's going to equal to my y value, which is adjacent. So 83 times cosine of 22, that'd be 76.95 or 77.0. So what we have is for vector 1, the x and y component. X is going to be 31.1 in the west direction, and y is going to be 77, and it's going in the north direction. I can say since it's x, this is going to be negative, but to keep the value, since I know it's going west and all my other directions going west, I'm going to keep this positive for right now. So so my vector, my x and y components for vector 2. Make sure I label this right. This is 21 degrees. And this vector, if I think, is 146. So 146, we just take 146 times the sine of 21. Still opposite over hypotenuse. So multiply both sides by the hypotenuse, and you're going to get the opposite, which is my x direction. So 146 times the sine of 21. Make sure your calculator is in degrees. The biggest mistake people have with these calculators, scientific calculators, is sometimes they're in radians. That comes from math classes. Math deals with radians. Physics deals with degrees, especially for in the initial freshman, sophomore level classes. You will get to radians. If you continue on with physics, you will get to radians a little later. However, for this class, it will be nothing but degrees. And you're probably going to hear me say this over and over again. So 146 times the cosine of 21. That's equal to my y. 146 times the cosine of 21. That's going to give me 136. All right, so my third vector, this is the one that is going more in the westerly direction than what we think. That's 152 and 17.5. So this is 152, 17.5. You should get the idea now. 152 times 152 times the sine of 17.5 will actually give me the y direction, because this is the opposite now going up, and the adjacent is on the side. So 152 times the sine of 17.5. That's going to give me the y, which is 45.7. And now my 152 times cosine of 17.5, which is giving me my adjacent, which is x, which is going to be 145. And there are my three vectors. Add these together. So my total sum of the x in the west direction is going to be 0.44. Let's see, 4, 5, 6, 7, 5, 97.4 in the x direction. Whoops, no, I can't add. 197, I believe. So I try to do this in my head, and sometimes I get confused with 228. 228.4 in the x direction, and the y, 77 plus 136 plus 45.7. You're going to get 258.7. So I'm going to go to my next slide. Whoops, can't do that. So the components. I'm going to come over here. Get back to my pen. Let's go with black. Change this up. So my x direction is 228.4. My y is 258.7. And we want to know what this vector is. We need the angle and the distance. Well, guys, a squared plus b squared is going to equal c squared. So 228.4 squared plus 258.7 squared is going to give me c. So what I'm doing is 228.4 squared plus 258.7 squared is going to give me c squared, which is this. C squared. So if I take the square root of these two numbers, I'm going to get 345.0. So my distance, my displacement is 345 kilometers. Now I'm looking for this angle, so it's somewhat west of north. So the tangent is going to be opposite over adjacent. It's going to give me a value. So tangent, parentheses, opposite is 228.4, and divide by 258.7. And I want the angle, not, so it's going to be the inverse tan. So, sorry about that. So inverse tan. See how you can make mistakes? Because I realized I didn't get an angle. I had 0.015 as my answer. And I'm like, that's not the angle. So I know I made a mistake. So remember, tangent of the angle is equal to opposite over adjacent. So you do the inverse tangent, opposite over adjacent will give you the angle. So again, 228.4 divided by 258.7. And that'll give me 41.4. So this angle is 41.4 west of north. Because here's my north axis directly up, and I'm 41 degrees west of that. So the answer is 345 kilometers at a direction of 41.4 degrees west of north. And there is my final answer. This is what I'm looking for the test. Hopefully not as messy, but you get the idea. If you have any questions, please see me during Scott time or during class hours online, and I will see you guys later.